Good day, students. So, this video I'm going to do on 9.1 and 9.2. In this video, I'm going to teach you what is relative atomic, molecular, as well as formula mass. Take a look with me. Meet Alice. Alice weighs 12 kg. Meet Belle. Belle weighs 24 kg. Consider this statement now with me. Belle's mass compared to Alice is 2. How do I get this 2? Well, what I have done is I took Belle's mass and I divide this with Alice's mass. So in this case here, it's actually 24 kg divided by 12 kg. When we are comparing and dividing in this way, we cancel out the units and 24 divided by 12 give us 2. That is why Belle's mass compared to Alice is 2. And there is no units. Another word to say compared to is Belle's mass relative to Alice is 2. Now, let us consider another case. Let us look with me to this statement here. Belle's mass compared to 1/12 of Alice's mass. Now, in this case here, what happened is that instead of taking Alice's mass as 12 kg, I want Belle's mass to be compared to 1/12 of Alice's mass. In this case here, my answer is 24. And this 24 comes about when I take Belle's mass and divide it by 1/12 of Alice's mass. And that, students, will give me 24 divided by 1/12 times 12, which gives me 24 divided by 1. Now, students, the units in this case here, okay, students, the units in this case here cancel out. Okay, so as a result of this, it has no units. So this answer becomes 24. Again, there is no units. Now, let us consider this case, slightly special case. Instead of taking Belle's mass to compare with 1/12 of Alice's mass, I am now taking Alice's own mass and comparing it with 1/12, okay, of Alice's own mass. So in this case here, my answer will be 12. And this comes about when I take Alice's mass divided by 1/12 of Alice's mass. So in this case here, it actually equals to 12 kg divided by 1/12 times 12 kg. That makes it such that it becomes 12 kg divided by 1 kg. Again, the units cancel out. So as a result of this, the answer becomes 12. This, student, is the concept of relative. In this case here, all the various mass on this side here, okay, is actually made to compare with another quantity. And if we were to number case 1, case 2, and case 3, you will observe that case 2 and 3, they are always being asked to compare with 1/12 of Alice mass. Now, students, with this understanding of what is relative and comparing it to a certain quantity that involves this 1/12, we will now go on to explain what is relative atomic mass. Now, students, according to your textbook, the relative atomic mass of an element is defined as the average mass of one atom of the element compared to 1/12 of an atom of carbon 12. Now, students, this is the formula way of defining relative atomic mass of an element. If you are required to answer the definition of relative atomic mass of an element in words, all you need to do is to remember this equal sign. You can replace this equal sign with is. And you can replace this red line with the word compared to. Okay. So maybe this is not very clear. Allow me to write that this line. All you need to do is to replace this line with the word compared to. Okay, so it will read the relative atomic mass of an element is an average mass of one atom of the element compared to 1/12 of an atom of carbon 12. This is how you can help yourself to remember the definition. Now, let me give you an example of how this works. Consider with me an example here. Now, this example, okay, I will need you to refer to your periodic table. There is this element, okay, which has a proton number of 6. The symbol is C. It has a little word carbon written over there, and it has a relative atomic mass of 12. How do we get this 12? Well, if you were to apply this formula, what happens is that the average mass of one atom of the element, okay, in this case here is carbon here, is 12. And then you divide it by 1/12 of an atom of carbon 12, which is actually 1/12 times 12. The units actually is what this thing called atomic mass units. Now, this units is not very important to you now, so I'm just writing it so that you know when we want the relative atomic mass of an element, they actually cancel out, and if you work this out, this becomes 12. Now, let's consider another example. Okay, another example that you can consider is your oxygen. Now, your oxygen from your periodic table, okay, has 8 atoms. It has an atomic mass of 16. So what this 16 simply means that the average mass of one atom of the element, okay, in this case oxygen, okay, divide, okay, by 1/12, okay, 1/12 of an atom of a carbon-12 is 1/12 times 12, okay, AMU, atomic mass unit, not very important, it cancels out, okay, and what happens is it becomes 16 divided by 1, and this is actually 16. So students, this is an example of how you can actually obtain, okay, the relative atomic mass of an element, which usually you can find from your periodic table. Now, students, if you look with me to this equation here, there are something I want you to take note of. The first thing I want you to take note of is that I wrote the word average, okay, in blue. Now, students, why do I need to write average? Now, students, if you recall, not all the atoms, okay, not all the atoms of the same element, okay, has the same mass. Okay, the question here is why average? Why must we have the word average in there? Recall for me chlorine. Okay, your chlorine has on Earth, okay, on Earth, what happens is that the chlorine atom on Earth, 75% of it, right, exists as chlorine 35. Well, 25% of it, okay, exists as chlorine 37. If you recall, these guys are isotopes. Isotopes, okay, are atoms of the same element with different number of neutrons. Now, in order to find the relative atomic mass, in this case, to find an average mass, what happens is that we actually need to do this calculation, which is actually 75 over 100 times, okay, your 35, and then subsequently add 25 over 100 times 37, okay, and that will give you 35.5, okay, and this value here, student, and this explains why if you look at your periodic table, your chlorine has a relative atomic mass of 35.5. Now, students, if you understand that the relative atomic mass of an element is simply just the average mass of one atom of the element divided by 1/12 of an atom of carbon-12, you will understand that if I were to replace, okay, if I were to replace this term here, atom, okay, with the word molecule, okay, I'm just going to draw a little star here. I'm going to replace it with the word average mass of one molecule. Okay? Okay? Of one molecule. Okay? And then further go on to replace this word element, okay, with either element, okay, I'm going to use a little funny shape like this. If I were to replace this word element with, okay, either element or compound, okay, you will find that now this term here becomes the average mass of one molecule of the compound or element relative to 1/12 of an atom of carbon-12. If that is the case, when these words are replaced, this thing now is called the relative, instead of calling it the relative atomic mass. This thing now becomes the relative molecular mass. Now, if I go on in the same way, to replace this word here, the average mass of one formula unit, okay, now if I go on to change it to formula unit, of the ionic compound, this term will no longer be called the relative atomic mass of an element, but however, it will be called the relative formula mass. Okay, it will be called the relative formula mass. Okay, and these two terms, okay, students, are both represented by the term mR. The relative atomic mass of an element, however, is represented by the symbol AR. The little subscript R represents relative. A stands for atomic, A stands for atomic, M stands for molecular mass or relative formula mass. In this case here, excuse me, relative formula mass applies to your ionic compounds, whereas the relative molecular mass usually applies to your covalent molecular structure. So, let me clean up this board and show you how they are related. Now, students, let us consider the relationship between your relative atomic mass as well as the relative molecular mass or the relative formula mass. Now, to find the relative molecular mass, all we need to do is to take the sum of the relative atomic mass of all the atoms in, well, the molecule. 1. Sum of the relative atomic mass of all the atoms in the molecule would give you the relative molecular mass. The sum of, in order, however, for us to find the relative formula mass, and a quick recap, the relative formula mass basically applies, for ionic compounds. This applies for ionic compounds. To find the relative formula mass, all we need to do is to add up, basically take the sum of the relative atomic mass of the atoms in the formula of the ionic compound. Now, students, to make this easier, let's do an example one by one. Let's consider on finding your relative molecular mass. Basically, it is the sum of the relative atomic mass of atoms in the molecule. Let's consider a molecule. Let's consider H2O. To find the MR, okay, of H2O, all we need to do is to take 2 times 1, because 1 is actually the AR of hydrogen, okay, plus 1 times 16, because 16 is actually the AR, okay, of your oxygen, and this will give us a total of 18. Taking note that there is no units, because this is a case of comparing, okay? Now, maybe just one more example. Let's consider we want to find example A here, okay? B, okay? We want to find the MR of your CO2. That, students, can be found by taking 1 times 12, because 12 is actually the MR of CO2, okay? Add 2 times 16, because this is actually the MR of your oxygen. Sorry, this is actually the, okay, sorry, I made a mistake. This 12 here is actually the relative atomic mass, the AR of carbon, and this is actually the AR, relative atomic mass of oxygen. So that, students, is equal to 12 plus 32, which gives us a total of 44. Again, remember, there is no units. Let's consider another case here to find the relative formula mass. Okay, so in this case here, what we can do is to consider, okay, for example, the formula of one of the ionic compounds. Now, the formula of an ionic compound, okay, let us consider this example. Now, as I was saying, let us consider, okay, first, your sodium chloride. Now, to find the relative formula mass of my sodium chloride, that would actually be equals to 23, okay, which is actually the AR, relative atomic mass of your sodium, okay, plus 35.5, and that, student, would give me a total of 58.5. Taking note that there is no units. Let's consider another example of determining the relative formula mass. Now, consider with me another ionic compound. It's actually, okay, your lead nitrate. Now, your lead nitrate, right, has a formula of Pb, okay, bracket, NO3, and the whole thing bracket up. Now, what happens is this case here, you will have to find the MR of lead from a periodic table. This is actually 207. This is actually the AR of lead. Okay? And in this case here, nitrogen. But this nitrogen, students, you have to remember there's actually a 2 here. Okay? So as a result of this, you need to times 2. Okay? You need to times 2. So that becomes 2, okay, times your nitrogen. And nitrogen from your periodic table, okay, has a relative atomic mass of 14. And next, okay, this is actually your AR of your nitrogen. And next is oxygen. Now, oxygen, you need to actually take 2 times 3. So it's actually 2 times 3 times the relative atomic mass of the oxygen, which is 16. Okay? So once you do the maths, you will find that this add up to be 207 plus 28 plus, okay, 96. And this will give you a grand total of 331. Okay, students. And as a bonus, before I close this chapter, I'd like to introduce to you a situation of your very familiar copper sulfate. CuSO4. Now, students, your copper sulfate, this guy, right? Sometimes when it's crystallized, it will have water trapped in it. When this happens, right, students, the water that is trapped is what we call the water of crystallization. And what happens is that sometimes in the formula, they will tell you how many, okay, molecules of water are there in one molecule, okay, in one formula unit, okay, because ionic compound, you have to say formula unit, okay, in one formula unit of copper sulfate. So in this case here, if the number of molecules of, okay, water of crystallization is 5, you will sometimes be shown this equation. Students, I do not want you to panic when you see this. This simply means that if I want to find the relative, okay, formula mass of this whole thing, all I need to do is to do the same thing. So copper, okay, copper has a relative atomic mass of 64 and sulfur 32 plus 4 times oxygen, which is 16. Now, students, if you remember with me, your H2O, okay, your H2O over here, okay, we've actually determined over here, okay, that it has a relative molecular mass of 18. So, as a result of this, right, students, all we need to do is to put 5, because 5 and 5, okay, 18. And once you press the calculator, students, you will find that the relative, okay, formula mass of this copper sulfate along with the water of crystallization is actually 250. And again, there is, take note, no units because we are talking about relative, okay? The units cancel out. Now, students, this, okay, is the topic on 9.1 and 9.2, okay, determining relative atomic mass, determining relative molecular mass, as well as formula mass. Thank you.